Now back to our first tab on the left here, we've got our tool tab. Now this is where we set our feeds and speeds and also select our tool. And this is our third way of accessing the tool library, and that's internal within the program. Now once I'm in the tool library, you'll see that I'm inside of the pump front cover part, and I have no tools selected. So this is where I want to cruise down into my library structure and search out a face mill tool to go ahead and face this part. Now let's go over setting up a tool library real quick, as I have several libraries inside of HSM. Now by default, the libraries are actually set up on your user account in your C drive. However, it is a good idea to go into HSM and go into your own server and create a custom library for everyone to use within your organization. Now, you may want to come down here and select this new library tab. Now what happens when I select this new library tab is that it adds a new library on top of a library that already exists. Now the problem with this is that this could be pointing back to my user account. So what I really want to do is I want to right click out in the white field where I get the option to add a new library folder. Now this is a folder, not a library. That's the difference between the two. When I click on this, it brings up my Windows browser dialog, and this is what allows me to navigate externally into Windows and create a new folder that's going to be my library folder. I'm going to go ahead and put it on the server of my choice. I'm going to make a new folder. We'll go ahead and call this New Tools. Hit OK. And now I have a new folder library that's New Tools, and everyone can access this within my organization. Now, you're given a lot of default tools in HSM, and those are harbored here in this sample libraries. What I like to do is I like to actually take these tools and use them as I go to build my tool library. So what I'm going to go ahead and do is I'm going to come into Inch Tutorial. I'm going to use their face mill for starts. I'm going to select this for this tool path. Now what that did is that actually put that tool into this program. So it pulled it from the library source into the part program. So it is basically a separate copy. So now I can make changes to this face mill. And it's real simple. All you need to do is right click and select Edit to open that tool up. And within that tool you can see that I have new tab selections, and the selections are general, cutter information. This is where I choose what type of cutter it is, and you can see that I have a plethora of selections to go through and select from as far as tools are concerned. The shaft, which is going to be an extra component on top of what you see as defined in the cutter definition as shaft diameter. This is for things such as necked down clearances, things like that. I have my holder information. This is the selection of the holder, and then I have my holder geometry information, and this is where each individual section is broken down geometrically to be able to use or change. Now by default, the selection is default holder, and it is pulling from a sample library. Now you cannot change sample libraries. You can't save over sample libraries, which is why I created a new library. But what you can do is you can copy and edit that tool holder, and that creates a copy internal to this program that we're in. Now from here I can actually come in and change things as I need to. So I can change this lower diameter to 750 if I wanted to. That increased the taper. I don't really see the need to do that, so I'm going to go ahead and cancel this out. Now one thing I do like to do is name my tools. So that's important to do, as this is what is going to be seen in the program, as well as setup sheets, and also how I like to organize my tools for the libraries themselves. So I'm going to change this from unspecified real fast, and this is the material type that the tool's made out of, to carbide. Those are going to be carbide inserts, and in the description I like to actually name the tool what it is. And with the name of the tool, I like to give it the amount that I can cut with it. I'm going to go ahead and say 0.100 flute length. And that may not be the actual flute length or size of the insert. This is just, again, what I can cut with it. This is a reminder to me how I would like to use the tool, and at the same time what I can do is set up a standard for my shop to be able to use as a blanket statement. This insert cutter only cuts 100 thousandths max in any given material that it's used for. You'll have to create your own standard operating procedures for that. But a big ticket item that I like to do is I like to go ahead and add the material. And for me, I abbreviate just about everything. So I'm going to go ahead and do an alum for aluminum. And I copy this description directly over into the comments. Now you can use the vendor if you have specific vendors that you like to go through, and you can use the product ID and actually insert the insert numbers as you like. But for our demonstration today, what I'm going to go ahead and do is not bother with those and go ahead and continue on. Within the cutter, you'll see that it's got a face mill selected already. I'm going to go ahead and leave the defaults the way they are. They're actually perfect. What really matters is that the diameter is set correctly and that the feeds and speeds are set correctly. Here's where it becomes important to understand how your tool libraries function, because this feeds and speeds will only be set within the tool that's inside the pump front cover at this time. So it's important to remember that. So if I change this feeds and speeds to whatever I want to change it to, and in this case this is aluminum, so I'm going to go ahead and change it to 8,000 RPMs. I'm going to go 60 inches a minute for the machine tool that I'm working on. I'm going to leave the ramp feed rate at 30, and I'm going to change the plunge feed rate up to 60 as well. That way it quickly plunges outside of the stock down into the material. Now it's important to remember that this could be dangerous. Always be sure that you're not going to plunge inside of stock whenever you're making this definition for your plunge feed rate. Now that also brings up whether or not I'm using this tool for a special need, and oftentimes what I'll do is I will name it in this as facing or face. Now if I'm doing something else such as plunging, I can change that feed rate to be able to plunge mill with it if that's the case, if it is an insert cutter capable of doing that. And I have something within my library, I'm going to hit OK for all of those selections, that gives me a little bit of information on the description of what I can do with it. I can just as easily come in and change that back, change this back to face. Every time I change something in the library, it's just letting me know that it will always be doing this. For this, I'm going to do this and never show this message ever again. I'm going to select that tool now to be able to face this part. And you'll see what happens here is the feeds and speeds are automatically changed and repopulated with the tool's feeds and speeds. This is very important to understand in every toolpath in HSM, as if you select a different tool, it is going to automatically change these feeds and speeds to that tool's feeds and speeds. Now, that doesn't mean that you can't come in and change this. Let's say you're posting this program to a machine that can't do 8,000 RPMs, and it only goes up to 7,000 or 7,500 RPMs. Then you can come in and change that within the program. Now, it will stay this way as long as I do not change the tool again. But if I come back into the tool, reselect that tool, it'll automatically re-update. Inside the tool library, before I leave here, what I do like to do is after I have that set, is I'll come down to my library that I want to save this tool to, right click, I'll create a new library. Again, this is a folder and this is a library. I'm going to call this Alum Tools. That's my aluminum cutters, and I'll come back up to my pump front cover, right click, copy that tool, come down, highlight that library, right click and paste it. Now that tool's in there for everyone to use. Those are proven feeds and speeds, and I know that I can use this cutter as I'm using it speeds and feeds wise in the future, so I can always come down here and now pull that from the library. It's just as easy to cut, copy, and paste anything else within HSM. Again, all Windows functions work. I can right click and I can duplicate this toolpath, and you can see there are shortcuts to all of these. Control X is cut, of course, just like Windows, and copy is Control C, and paste is Control V. Duplicate is still Control D, so I can duplicate a cutter and I can change what I'm doing with the cutter. If I'm doing multiple things within a program with the same tool, but I need different feeds and speeds, I can control those feeds and speeds here. And there again, I can change this back to a plunge. And I can change these speeds and feeds to a slower feed rate for what I'm doing. Rename this particular portion of the cutter. Hit OK, and now I have two tools that are actually the same tool. So within the program, it's going to be using tool 1. There won't be a tool change, but the speeds and feeds will change for the function that I've chosen it to do. And if I change that function, you'll see that it updates my tool itself. I'm going to go ahead and change this back to face. Bring it back up to 8,000 RPMs and continue on. Now I'm going to go into the Geometry tab. It's important to understand that HSM will only give you the pertinent information per toolpath that you selected. In this case, in the face toolpath, it's very straightforward and simple. It only needs to know where the stock is. This is also important to understand that the face toolpath by default will always want to violate a boundary, and by that I mean it wants to go on the outside of the boundary. It's trying to clean up material and trying to clear what's defined as the stock. As HSM is very model smart, it knows that this is the solid that we're going to be machining, and the defined stock, as represented by this rectangle, is the stock itself. Now by default, again, the facing toolpath wants to clear these numbers. I'm going to see that in a moment in our fourth tab, which is our passes tab. Let's jump over to our heights tab. Now the default heights are kind of a safety setup for HSM. What I like to do is start changing these to my particular needs. The first thing I like to do is inside of each toolpath, these are going to change based off of the needed geometry. The selections for your top height and your bottom height, which is the top of your cut and the bottom of your cut, are generally set default correctly. It begins getting a little different for what you may want to do with it when you select your feed height, your retraction plane, and your clearance height. Now what I like to do is use these drop-down menus here to select what I like to do for my heights in particular. And for anything starting out facing, I'm usually going to want to clear the stock itself no matter what. Occasionally I may get stock comes in a lot bigger than what I may have programmed it. Now by doing this, I can take and go to the stock height top, define my stock as its biggest point, and always feed from 2 millimeters above that stock top. The same goes with the retraction height. I like to be a little closer on my retract move, so I may drop that down to say 5 millimeters, and then I will always have my clearance height be from the stock top as well, and just be far enough above my stock height to clear it. In this case, I'm going to leave it default at 25.4 millimeters, roughly an inch. Moving on to our passes tab, you'll see that I have my tolerance, this is the deviation tolerance that the output of the code is going to use. I have my pass direction. If I change this to 0, this is more than likely going to be from a 90-degree setup. And you'll see that I used my block. Again, if I come up here to my tool top, that's going to line itself with its WCS and not with the world coordinate system. At 0 degrees, using the 3 o'clock rule, which means that you always start things off at 3 o'clock and move it around, that means that I'm going to be directly along in the X direction. If I were to switch this to 90 degrees, then my passes are going to be created in the Y direction, which is what I want for this part. I want to be able to feed into my jaws, my vice jaws, in that direction for the most rigidity. That's pass direction in degrees. Pass extension, this is the amount that it's going to overlap past the boundary of the stock. And if you hover in any toolpath in any of the dialog boxes in HSM, you'll see that there is just a little added information that you can get from these little tool tips. And this can give you everything you need to walk yourself through these toolpaths. Stock offset, this is the amount you're going to go past the part in addition to the stock. So if your stock boundary is set up a specific amount past your part and you wanted to travel past that stock amount, you can add it here. That's not pass extension. It's important to understand that pass extension goes past this boundary. That stock offset actually extends the boundary of the stock. Your step over amount is going to be an automatic calculation based off of the diameter of your part. Now, this may or may not be what you want. You can change this however you need to. You can also set these defaults in a particular way, and that's a more advanced setting, but you can come in and edit the expression and then change the mathematics that are actually calculating these things. We'll go over that in another video at another time. The next is the direction control, which is a drop-down menu, and I usually like to keep this to both ways with a facing toolpath, as I don't mind the directions being changed back and forth whenever we're fully engaging material. From other side is going to control what side it starts on, and that's going to be the opposite corner from wherever the start point of the engagement is based off of the angle. And use chip thinning. Now, use chip thinning is going to give you a tricordial motion in the direction using what's more of an engagement style toolpath to be able to face the part. This is really good actually for roughing large amounts of material off, but otherwise you're generally going to stay with a traditional facing operation of both ways. Multiple depths gives you the ability to clear material. Again, if I hover over it, you'll see that I have a explanation of how this works. If I add a finishing step, you'll see the dialog box opens itself up to be able to be used, and I can change the finishing allowance. In this case, I'm just going to go straight to 0. I'm not going to worry about that. And then stock to leave. I'm going to uncheck stock to leave as I'm not going to use it, and you can see that that truncates out of the way. And that's how HSM is set up. If you aren't using a particular tool, it pulls it out of the way. If you need to use it, you can open it up and then you can access the dialog box, which is a really nice thing as a programmer to be able to not have to deal with these things on a regular basis if I have a toolpath that I know that I like to use a specific way. Moving on to our final tab, and that's going to be our linking tab. These are, again, passes that are going to be between cuts, between parts, and at the beginning and the end of the feed movement and the retraction movement of the part. Now, how they've broken this down is they have the linking segment and the lead-in, lead-out segment. Now, the linking segment, again, is this controls how it's going to engage the next cut between selected geometry. In this case, there's only one thing that it's going to be doing. However, I do want to turn Keep Tool down, as this is a stock cutting toolpath, and it's quite possible that it could be something in the way at the top. I want it to retract between each and every move. Allow rapid retract is something that usually is set default commonly. We're going to go ahead and keep allow rapid retract on. Extend before retract, we're going to leave that off. That's going to add more feed rate to the retract itself. And then we're going to come down to our lead in, lead out. Now, by default, the facing goes past our stock, so it doesn't give us the typical lead in, lead out that you would expect out of most CAD CAM. It does give us this vertical lead in, lead out, and for high speed machines, you may want to use this. I personally don't see the point, as I'm not machining anything at this point. I'm plunging down into air, so I like to keep this set as 0. Now, by default, you may actually see a value in here starting out. HSM, you'll see these two values in here. It's okay to go ahead and hit 0 on this, clear that out. Transition types, this is going to be between the toolpaths themselves, and typically for facing, I'm going to keep with a smooth transition. That's going to give us a smooth arc between each toolpath. You can change this by no contact, which is going to rapid retract. Straight line, which is just going to cut squarely over. And shortest path, which is choosing the path that is the fastest to move. I'm going to go ahead and stick with smooth. I'm going to hit OK, and that's going to calculate this facing toolpath. Now, if I look at this toolpath, even though I had smooth selected, there's actually the keep tool down has been shut off, so it is rapid retracting. So let's go ahead and edit that real quick, and you saw how fast I can select things within the toolpath. If I right click on it, there's a whole right click menu that I can choose from, and the very top item is edit. Left click in there, I can come back in here, click keep tool down, I'm going to hit OK. And now you can see that it has added those loops. So if I feel that it is safe, I can go ahead and keep tool down, and this is just going to feed and create arcs between each toolpath. Now that I've created that face toolpath, I may want to actually take and make this a default. That means that I want to make all the values within this face mill toolpath default. Now HSM makes this incredibly easy. It's in the right click menu of the toolpath. I can just right click on this and in the middle here you'll see this make default. If I left click on that, that's going to actually make every face mill toolpath default. Now what that means is if I double click on a toolpath to get into it, again that's the same as right click and edit, you'll see that I have these values set at stock 5 millimeters. Now watch this retract height stock 5 millimeters. If I create a new face toolpath and go straight over to the height, you'll see that that automatically has that set up from the stock 5 millimeters for me, so that I no longer have to worry about setting that setting every single time I start a face toolpath. So very handy, very easy way to make a toolpath default. Just right click on it, make toolpath default.